All right, y'all, let's look at example 8 that we did not get to complete yesterday. So this says that a ball is thrown upward with a speed of 48 feet per second. So what information is that giving me?
The velocity.
The initial velocity, correct?
Yeah.
So our initial velocity is 48, and it's positive because it's being thrown upward from a cliff 432 feet above the ground. So that is your initial position.
And since it's feet and it's negative 16.
And great, since it's got t in it, that means when I write my quadratic, my a value would be negative 16. Because it's feet, the time is feet, not meters. That's not time, that's distance. So the distance is measured in feet, not meters. That's why we would use the negative 16 for your a value. So find the position function.
Since it's thrown upward, it's plus 48t.
Yes, it is. So that would be negative 16t squared plus 48t plus 432. When does it reach the maximum height? So when it reaches its maximum height, what is the velocity going to be? 0. So wouldn't it be easy just to take the derivative of this and find velocity and then set that equal to 0?
Heck yeah.
Isn't that faster than actually finding this maximum point?
Heck yeah.
So let's find our velocity formula. Negative 32t plus 48. Set that equal to 0.
1.5.
Solve it. Time is 1.5 seconds. When does it hit the ground? What would I need to do with that? Set the original position function equal to 0. And how would y'all go about solving this? Would you try to factor out a 16? Does 16 go into 432? So let's divide everything by, you want to go ahead and do negative 16? Okay, so t squared, subtract 3t. How many times does 16 go into 432?
27 times.
27 times equals 0. Now can we come up with something that multiplies to be negative 27, but adds to be negative 3?
I don't think so.
No, we can't, so we can't do factoring.
Quadratic.
So use the quadratic formula, which is going to be much easier to do with these smaller values.
Josh, that's the quadratic formula.
This gives us two answers, but am I really interested in the negative value for an answer? No. So the only thing you would really need to calculate is 3 plus the square root of 117, and then divided by 2. So what happens to 3 plus the square root of 117 divided by 2?
6.9.
6.9 seconds. So is there anybody who's having trouble remembering this formula? Okay, all right. So if you have trouble remembering that formula, do you know that if we're talking about feet, that acceleration due to gravity is negative 32? You do know that. So if you know that, you can start out with this. Your acceleration constant is negative 32. To find velocity, you would integrate this, negative 32t plus c. Now, don't we know that our initial velocity is 48? So that means when you input 0 into this, it should equal 48. So therefore, c will be 48. So now we know our particular velocity formula is this. Now to find your position function, you would integrate that.
And that's why you get the negative 16.
And that's how we get the negative 16t squared plus 48t plus d. And this information told me that if I input 0, I should get 432. So if you put 0 into this, 0 plus 0 plus d is 432. So that's how you can find your position formula using antiderivatives without having to just memorize another formula.
What's the one
For
for meters?
meters,
Is it 9.8?
acceleration due to gravity is negative 9.8 if you're talking about meters per second squared. Okay? All right. Will you stop that recording?
Cut.